Now we will start the first unit with this topic, that is type of external forces. Now different types of force we will study here. First force is tension. Now what is tension? If you have any body like this and you are pulling that from both sides, what will happen to that body? It will get stretched. When body is getting stretched, that time we can call it as the body is subjected to tension. The example of this force you can see by the rubber. If you are pulling this rubber, what will happen? This is getting stretched. Then we can say that rubber is subjected to tension. Now we will come to the next, that is compression. Now we will consider one more body and we are applying force like this. Now what we are doing here? We are pressing that body. Whenever we are pressing that body, then what will happen? The shape or size of that body will get reduced, and we can call it that body is subjected to compression. Now the best example of this, if you take a eraser and if you are trying to compress that, what will happen? It is getting compressed. Whenever you are pressing that rubber, it will getting compressed, and that is called as compression. We'll come to the next, that is bending. Now bending, we can say that a force applied over a body that causes a curvature. We'll take a body, one body will take like this, a simple beam we can take, and if you apply a load over here, force over here, what will happen? This will become like this. This is main original shape, and this will become deformed shape when after applying the load. Now here we can say that the body is subjected to bending. Okay, then we'll come to the next, torsion. For torsion, we can say that a body is subjected to torsion when we are applying twisting. When we are twisting that body, or we are applying twisting movement like this. If this is the scale and if I turn like this, if you can see here, if I turn like this, what is happening? It is getting twisted. This type of force we can call it as a torsion. Okay. The next thing we will study here, the shear. Now shear force is nothing but whenever we are applying a force on a body parallelly but equal and opposite direction, with equal magnitude and in opposite direction, then what will happen? This will become like this, isn't it? Now whenever such cases we are finding, that time we can say the body is subjected to shear force. Now the best example for this is scissor, which is applying equal and opposite direction force with parallel. Now if I do like this, what will happen? Body will get deformed, isn't it? So this is the best example for the shear force. Now we will study the materials, different types of materials and properties of those. Basically, engineering materials are classified in two types. First one is metals and second one is non-metals. Now in metals we can give the examples like mild steel, copper, silver, gold, and their alloys. And in non-metals, wood, plastic, rubber, these are classified in non-metals. And if we want to classify these metals, we are basically classified in two terms. First one is ferrous and second one is non-ferrous. Now, ferrous materials are those which having content of iron, and non-ferrous materials are those which doesn't having any content of iron. Now, how we can identify those? If magnet attracts any material, any metal, that time we should understand that that metal is made up of, or that is ferrous material. And if any metal doesn't attract to the magnet, that time we have to understand that that is non-ferrous material. Now after this we will study the mechanical properties of materials. Now here we are going to study different properties of materials. First one is now what is elasticity? Whenever term comes elasticity, we must understand that this property, for this to explain this, I'll take one rubber band, and if I apply a load on this, it will get stretched, it will get deformed. But if I release a load, what will happen? It will come to its original shape, isn't it? See, if I apply a load, it is getting stretched. If I release a load, it is coming back to its original shape. Now this type of, or this property, we can call it as elasticity of material. Any material you can take, it will get deformed when you are applying a load under the elastic limit. This point is very important. You have to apply a load, but under the elastic limit. If you are applying a load beyond the elastic limit, then it will getting a permanent deformation. If I stretch this rubber more than its capacity, what will happen? It will get break. It will get deformed permanently. It will not come again to its original shape. Okay. To understand that property, we should have the knowledge of one more property, that is plasticity. Now, here what will happen? If we apply a load beyond the elastic limit, what will happen? Material will get permanent deformation. To explain that, I'll take one wire. Oh, this is steel wire. Okay. I'll apply a load. See, I'll apply a load and I'll release. It is coming back to its original shape. I'll apply a load, I'll release. It is again coming back to its shape. But if I apply a load beyond the elastic limit, what will happen? Is it coming back to its original shape? No. See, this become permanent deformation. This is called as plasticity of a material. Okay. After that, we'll come to the next property, that is ductility. Okay. To To explain this ductility, when a material, any metal, if you are stretching, it is getting deformed. But you can see the thickness of that material is getting reduced. It is not getting deformed easily. First it is getting reduced, then after some limit it will get deformed. That reduction and of forming a thin wire, that property of material or metal is called as ductility. To explain this, I have to explain this property also, that is brittleness. Now, what I'll do, I'll take the same rod again. Okay. Now, if I apply a load over here within the elastic limit or after elastic limit also, what is happening? Is it getting break? No, it is not getting break. It is getting deformed. It is deforming, but it is not getting break. The same thing if I do with the glass, what will happen? It will not bend directly, straight away it will get break. Why? Because glass is brittle and still is ductile. Now to understand this, we have to compare the both things. One side you take a steel rod and one side you take glass rod. Apply a load, fix this side, apply a load. This rod will get deformed, but this glass straight away it will get break. To understand this clearly, I'll tell you one thing. This gives you a warning before it getting break. This will not give you any warning. Straight away it will get break. If you want, you can try this at home. Okay. After this we'll study another one. Now, toughness. What is toughness? Whenever you are applying any force on a body, that body have to absorb some force or load before it is getting deformed. That is called as toughness. This thing you can learn in MTQC lab, material testing lab. Now next is hardness. Hardness of any material. To understand this property, I'll take a chalk first. I'll take a chalk. I'll take a scissor. If you want, you can take a glass also. Now, if this is sharper one, if I scratch over here, what you can see? The scratch is forming on a chalk. But the same thing if I do over here or on a glass, will scratch will happen? No. Why? Because glass is more harder than this. If you take any aluminium metal, this is aluminium, and if you scratch over here, scratch will appear. But the same thing if you are doing with the glass, no, scratch will not appear over there, because you can say glass is harder than aluminium. Obviously, this can absorb more force compared to glass, but toughness is different, hardness is different. Hardness is, in general we can say that is scratch proof, and this metal is not a scratch proof. Okay, let us see afterwards that. Okay, then seventh property, that is strength. It is the ability of material to resist external applied force without breaking or yielding. Before it getting yield, it has to absorb maximum amount of force, that called as strength of that material. If it is getting bent, then what is use of that? It doesn't have that much sufficient strength in that. Okay, after this we will come to the next property, that is stiffness. This is the ability of material to resist deformation under stress. This is resisting deformation or yielding under a load, and this is under the stress. This is called as a stiffness. Resilience. Next is resilience. Now, resilience is the property which absorb more energy or more force under the impact loading. Whenever if you are impacting whenever you are impacting on a material, that has to absorb more load. It should not get break when you are applying impact load. It has to absorb more load, and such load absorbing property, we can say that resilience.